I'll be talking about why we need a maintainable and extendable NMR control vocabulary, hopefully an ontology, and how we could go there. Like, should we revive nmrCV or should we just try to integrate it with CHMO? And Philip will be helping me with the ontology technical issues. So in FTI4K, we already have NMR present in so many areas. We have NMR processing tools. It's also present in the Keymotion electronic lab notebook, and we have it in NMR repositories, nmrCV, which is specific for NMR, or in Keymotion, which includes other analytical techniques. Also, we have NMR in our terminology service, and also we are working on some standards for minimum information for NMR. In all these areas, we are already interested in using control vocabulary. This is why we have presented our ontology elements, which are elements that could help the users to use ontologies and ontology terms taken from the terminology service by picking some terms or by auto-completing while typing text. I'm not going to go into details about the ontology elements because Chandu will be talking about it tomorrow, so maybe I will just skip it here and move about our NMR needs in nmrCV. As I mentioned, nmrCV is a repository for NMR spectral data, and we have already identified some gaps in the available NMR controlled vocabularies. So first we have the issue with the chemical shift reference. There are some details about it in nmrCV, but as we could see here, we have chemical shift standard, and the parent, that is the reference, is kind of missing. Other than that, we have standards only for a couple of nuclei, and the rest is also missing. And within each method, we have kind of a mixture between standards and solvents, and it needs to be cleaned up a little bit. The other thing is the NMR solvents. Here also we have a photo from nmrCV, and we only have like 3 solvents. Many of the others are missing. We have collected a list of NMR solvents that we are interested in, and they are actually available in KB. But the problem is that in KB they are like just described in text that are they are NMR solvent, and there is no clear like relationship to say that this is actually an NMR solvent. There's also the problem in nmrCV that the solvents that are available, like they are inconsistent in terms of naming. We have like heavy water and small letters and such. The next topic is the acquisition nuclei. These are completely missing from the controlled vocabularies for NMR. They could be hinted to or infused in other places, like for CHMO. We can find the acquisition nuclei within the NMR method. Our approach currently to use controlled vocabulary to describe nuclei is to say the nucleus of an atom from KB. So the atom is the term that we are using, and we are just referring to the nucleus of this term, which is just a solution for the long run, but we need to have the acquisition nuclei in a more concrete way. The next thing is the NMR method. It's available in an extensive way in CHMO, but the problem is that the hierarchy is a little bit not clean enough. In the photo, we could see that we have, for example, 19F at the same level of two-dimensional NMR. So we don't have, for example, this one-dimensional as a parent for it. And it's like mixed with the dimensionality a little bit, and it needs a lot of cleaning. The next thing is the NMR instrument model. Here we have a photo from nmrCV. We could see how it's present in 2 different places in 2 different ways. And actually in the photo in the left, it doesn't make much sense because we don't really have the model. So what we measured is the needs for nmrCV, which is a repository for NMR spectra data. We also have some needs for NMR minimum information that we are currently working on in NFTI4K. So we are working on minimum information for the users, what to report when they are what metadata to report while reporting an NMR experiment. And we have found that very crucial terms are actually missing, so we can't provide a clear definition for the users about what we are asking for. Here are the list of the missing terms. And next, I think I will hand it to you, Philip.
Thanks. So recapping a little bit, what we have right now is the NMR controlled vocabulary, nmrCV version 1.1. And as Nora just said, it is a rich taxonomy for NMR assays, but it has gaps. And also, if you look into it, some of the terms are lacking a proper description or definition. And just as a recap, it was developed as the controlled vocabulary part of an XSD validation pipeline to be used with the NMR-ML format, and thus deliberately left out any axiomatization, which is problematic when it comes to what we've just seen, having to define the NMR spectroscopy method under different grouping classes, let's say 1D NMR spectroscopy or sorted, grouped by acquisition nucleus. Another thing we need to note about this CV is that although it is BFO 2.0 aligned, with some little errors, it is not aligned with the other OBO ontologies, which means there are some orthogonality issues because there are term overlaps with IO, OBI and such, and also some subsumption hierarchy differences. So if one were to use nmrCV along with OBO ontologies, for instance, to create knowledge graphs, which we would love to do in the end, this would make things a little bit harder. With regard to CHMO, some things I have said earlier, it has some harmonization issues. Luckily, it is aligned with BFO 2.0 and many OBO foundry ontologies. It is thus semantically richer, and but the problem is the terms that it lacks, which are present in nmrCV, cannot very easily be directly imported due to the way nmrCV is built. So this is unfortunate. And another thing with regard to NMR spectroscopy, as Nora just said, the current branch for the NMR spectroscopy assay is rather, could be improved in terms of grouping and sorting, but having the possibility to use object properties to do so. For instance, 1D NMR spectroscopy assay is a spectroscopy assay using producing one-dimensional outputs, for instance, would be a viable route. But doing so is quite labor intensive. So we are currently at the stage of having a situation where we need new terms rather quickly. We have the fact that nmrCV is actually not actively maintained at the moment, but due to, for instance, Stefan, who's here on the call as well, having been involved previously, we might have the possibility to reboot the current NMR repository and reuse the namespace. So there would be the solution, or would be a possible approach to fix some errors in the current code, add new terms, keep the relatively flat, only hierarchical layout of this OWL ontology, and not add any properties to it. Or we could go down the road where we say, well, we do want to add nmrCV terms to CHMO and thus improve CHMO. But as I've said, this is a much slower process, and ontology engineering resources are very sparse. So also it seems to be better to first do things like move to an ODK-based repository. So there are a lot of other things that would have to be done beforehand. But the upside would be having more richer semantics. We could infer multiple inheritance with regard to grouping the spectroscopies according to different axes like dimensionality or acquisition nucleus. And also the problem with speaking about the acquisition nucleus, I think it might be possible to just reuse Cabi atoms and then do what Nora just said, more on a more formalized basis. And then having heard what NFTI for CUT is doing with the Excel to SCOS approach, there would also be the possibility to maybe use that, and definitely not to do a new ontology, because thou shall not reuse. Thou shall not reinvent the wheel, but reuse and improve what's already there, right? Yeah, but how about maybe using this Excel to SCOS approach to get things done quickly, which is why I was asking previously, how would we then do the richer semantics in another step? And how would this approach be suitable with regard to the problems that we have when we want to have kind of grouping classes? Would they be modeled as SCOS collections in themselves in there? So these are the open questions we have, and we hope that maybe among the participants here, you can give us some feedback on how we should proceed with this.